All right, here we go again. Let's do this. All right, this is going to be a little bit longer, but not necessarily more difficult. This is actually one of my favorite topics. Before I keep talking, pause me and copy that stuff down. Okay, so I always taught this to Calculus AB after the AP exam when I taught this, because the majority of students who take calculus are taking it because they want to get into some kind of math, science, or engineering, and they will then have the equivalent of Calc BC either in college or in high school, and you need partial fraction decomposition to be able to solve some of the problems in Calc BC. So this is a really important topic. It is not difficult. There is some stuff that you're going to have to memorize. Not a lot. It's not like trig identities or anything, but I personally think it's fun. So call me a nerd. I don't care. And Kaylee, don't comment on my YouTube video calling me a nerd. I know you want to. All right, so partial fraction decomposition is the opposite of starting with two fractions and giving them a common denominator to smush them together. We are going to pull them apart. And that's going to make operations that you will learn in calculus much easier. So, a few different cases. We're going to actually spend 3 days on this because there are different cases. That's what you're going to have to memorize. Non-repeated linear factors is the first and easiest case. First, though, before I'm jumping the gun here. Look this up in your book. It's easy to find. These terms are in bold, but make sure you read past the bold terms to figure out what you need to do when you have improper fractions, and then we're going to only be dealing with proper fractions. So write the partial fraction decomposition. We want to break this into two separate fractions. So the first thing that we're going to do, you probably guessed it, we're going to factor the denominator. And you can probably see that the two fractions that were added to get this fraction probably had denominators of x minus 2 and x minus 3, right? Each of the fractions. So what we're going to say is, we're going to say that this is going to be equal to something over x minus 2 plus something different over x minus 3. So we're going to make sure that A and B are different, because they might be the same, but that would be very much a coincidence. And then I literally just need to figure out how to solve this to find A and B. So the first thing I'm going to do is multiply both sides by the LCD. This goes back to that thing that I kept telling you guys over and over again, and I lost my marbles because we had to do a special quiz on it. Get rid of your fractions. Multiply both sides to get rid of your fractions. We're going to get rid of that, and we're going to get rid of that. If you still have fractions after you multiplied by the LCD, you didn't multiply by the LCD. You multiplied by something other than the LCD. So what I'm left with on the left is x equals, and then on the right side I've got a times x minus 3 plus b, right? A times x minus 3 plus b times x minus 2. Okay, there's two ways to solve it at this point. I'm going to show you both ways because we're going to do two examples. So the first one is called Equating the Coefficients. You'll see why it's called that in a second. Okay, I'm going to distribute in this method. Let me make sure I did that right. It's kind of late, and I want to make sure my brain is working. Yes, okay. And then I want to think of on the left side, I have a 1x, and then I have no constant term. So there's a 1 in front of the x, and there's no constant term. I want to get the right side to look like that as well. So I'm going to do this. And I want you to just think about that for a second before I explain it. So what I'm doing is I'm getting this to be set up exactly the same as this. I have something in front of x plus a number with no x involved whatsoever. Okay? And then this is where I'm going to equate the coefficients. If I have these two things that are equal, let me highlight this. I have the same format. Do you see that? This side is a lot more complicated, but it's the same format. If the left side equals the right side, then I know for sure that 1 has to equal a plus b. There's no way around it. The coefficient of x has to equal the coefficient of x. And for the left side to equal the right side, also 0 has to equal negative 3a minus 2b. The constant term has to equal the constant term. So in the equating the coefficients method, first we're multiplying by the LCD to get rid of fractions. Then we are distributing to get a like setup on both sides. So whatever's in front of x, and then there's a constant term, whatever's in front of x, and then there's a constant term. And then from here it's an algebra 1 problem. So we're going to solve this system of equations. Pretend it's an x and a y if it's bothering you that it's an a and a b. Multiply that by 3 so that I have opposites. Using elimination method, if you want to use substitution, you can, but I feel like this one's just set up really nicely for elimination. So combining 0 plus 3, combining negative 2b plus 3b, I get b equals 3, and then I can use 1 equals a plus b, so 1 equals a plus 3, so a equals negative 2. So the partial fraction decomposition, I want you to write this out, please. This fraction is equal to a, where'd it go? Negative 2 plus b, right here, over x minus 3. That is the partial fraction decomposition.